You know, you probably think the most important part of your vehicle is the engine.
Right. Or, maybe the transmission.
Exactly. But the truth is, if a $20 hidden sensor fails while you're driving down the highway, your $60,000 rolling computer is, well, it's nothing but a very heavy, very dangerous paperweight.
Yeah, that's completely true.
So today we're looking at the company that makes those sensors and the screens that actually display all their data. I mean, picture this. You're sitting in the driver's seat of a brand new vehicle.
Okay.
Maybe it's a sleek, modern passenger car, or perhaps you're straddling one of those high-end, next-generation two-wheelers. You haven't even started the engine yet.
Right. You're just getting settled.
Yeah, you just turn the key, or maybe you just push a button, and immediately right in front of you, the dashboard comes alive.
It's an experience, for sure.
Yeah. It really is. It's not just a glowing physical needle moving across a painted dial anymore.
Right.
It's this full-color, high-definition digital cockpit lighting up with complex diagnostics, range estimations, real-time tire pressure, and a dozen other critical data points.
Yeah, it almost feels like you're booting up a high-end laptop, not just, starting a mode of transportation.
Exactly. And while you're looking at that brilliant glass screen, there's a whole hidden world of unseen fluid pumps, temperature sensors, and control valves waking up under the hood.
Just perfectly synchronized.
Right, keeping the mechanical heart of that machine alive and beating.
It's a profound sensory experience that we've honestly entirely normalized. I mean, we've just
Sure.
come to expect that seamless orchestration of digital data and physical mechanics every single time we start a vehicle.
We really do take it for granted.
We do. We completely take for granted the sheer volume of precision engineering required to make a digital dashboard communicate flawlessly with, the gritty, high-temperature, high-vibration reality of an internal combustion engine.
Or a high-voltage battery pack now, right?
Exactly. It's an incredibly complex bridge between pristine software and heavy steel.
And that bridge, that exact intersection of the high-tech digital cockpit and the unseen mechanical plumbing, is the entire focus of our deep dive today.
It's a great topic.
We're going to unpack the story of Pricol Limited. They are a dominant Indian automotive components manufacturer, and they're quietly but very powerfully, I should say, powering the global transition from traditional mechanical vehicles to fully connected digital machines.
They're essentially manufacturing the nervous system for millions of vehicles on the road right now.
Okay, let's unpack this, because to really understand how they're doing this and, the scale at which they operate, we've gathered an extensive stack of sources for this deep dive.
We've got a lot to cover.
We sure do. We're looking at the company's annual reports, their detailed investor presentations, some sweeping industry analyses, and granular market share data.
Right, to get the full picture.
Yeah. We're going to look at their ground-level operations, their strategic shifts, and the underlying economics of how they manufacture these critical components. But before we get into the strategy and the whole global chessboard they're playing on, I think we need to establish a very clear physical picture of what Pricol actually makes.
Yeah, absolutely. If you don't understand the physical product, the rest of the business model just won't make sense.
Right.
So Pricol is fundamentally in the business of precision engineering. We are not talking about stamping out simple plastic cup holders or, floor mats.
Basic accessories.
Exactly. They manufacture over 400 different types of highly engineered product variants, and you can broadly categorize their entire empire into two main verticals.
Let's break those down for the listener, starting with, well, what I see when I sit in the driver's seat.
Right. So the first, and by far the largest, is what they call Driver Information and Connected Vehicle Solutions.
Or DICVS, right?
Yeah, DICVS for short. This vertical brings in about 69% of their total revenue.
Oh, wow. That's a huge chunk.
It is. And this is exactly what you were describing in the opening hook. It encompasses the instrument clusters, the digital dashboards, the telematics systems, and the connected vehicle modules.
So the whole interface.
Exactly. It's the human-machine interface. It's the screen that tells you everything you need to know about the vehicle's status, translated from raw mechanical data into legible digital information.
So if I'm looking at a screen on my motorcycle that tells me my battery life, my speed, my engine temperature, and maybe even connects to my phone via Bluetooth for turn-by-turn navigation, that is the DICVS vertical in action.
You nailed it.
It's the brain and the eyes of the operation.
Now, consider the second vertical, which is the mechanical counterpart to that digital brain, They call it Actuation Control and Fluid Management Systems.
Okay, ACFMS.
Right, ACFMS. Currently, this accounts for about 31% of their revenue, though, their internal projections expect it to grow to 35% soon. This vertical is all about the harsh physical realities of making a vehicle move safely and efficiently without tearing itself apart.
The dirty work, basically.
Exactly. We're talking about oil pumps that keep the engine lubricated under immense heat, fuel pumps that deliver precise amounts of combustible liquid, electrical coolant pumps to prevent overheating, and all types of sensors.
Like what kind of sensors?
Speed sensors, fuel level sensors, temperature sensors. It also includes physical actuators like idle speed control valves and automatic chain tensioners for motorcycles.
Wow, okay, so it's the plumbing, the reflexes, and the internal organs of the vehicle.
That's a good way to put it.
If the first vertical is the brain and the eyes, the second vertical is the heart, the lungs, and the muscles. And what really strikes me from our sources is that they are so deeply embedded in the automotive industry because they supply both sides of this equation.
Yeah, they have a very complete portfolio.
And they aren't just serving one niche type of vehicle either. Like, they are supplying motorcycles, scooters, passenger cars, towering commercial trucks, transit buses, agricultural tractors, and even heavy-duty off-road construction vehicles.
The scale of their application is just vast. And physically, their manufacturing footprint is just as extensive.
Where are they actually building all this stuff?
Well, they are currently operating 9 manufacturing plants.
9.
Yep, 9. 8 of those are spread strategically across India in major industrial and automotive hubs. Cities like Coimbatore, Manesar, Pune, and Patnagar.
Okay.
And they also operate 1 international manufacturing plant in Jakarta, Indonesia. On top of the physical factories, they maintain international offices in Tokyo, Singapore, Cologne, and Detroit.
So they really have a global presence.
They do, which allows them to export their products to over 45 countries globally.
Their financial footprint really reflects that global scale, too. I mean, looking at the sources, in the financial year 26, Pricol reported an annual revenue of 3,963.85 crore rupees.
Right.
So essentially just shy of a clean 4,000 crores. And for our listeners more accustomed to US dollars, that translates to roughly 410 million US dollars.
It's a substantial operation.
It is. And they are operating this sprawling enterprise with a workforce of over 5,500 employees.
What's fascinating here is not just their current revenue, but the ocean of opportunity they're swimming in.
How so?
The global total addressable market, or TAM, for this specific category, automotive sensors and instrument clusters, is projected to reach $33.8 billion US dollars by 2031.
Wow.
And it's compounding at an 11.8% annual growth rate.
That growth rate tells me this is not a stagnant industry where mechanics are just, replacing old, broken parts with identical new parts.
No, not at all.
The fundamental nature of these components is undergoing a historic transformation. We touched on this, but vehicles are no longer just mechanical modes of transport. They are rolling computers.
Exactly.
I mean, I look at an old mechanical speedometer with the physical needle connected to a spinning cable, and I look at a new digital screen, and I know they do the same basic job of telling me how fast I am going. But the technology behind them is worlds apart.
Yeah, the transition from analog to digital is being driven by a convergence of powerful global forces, the first of which is strict regulation.
Okay, like environmental laws.
Precisely. In India, the implementation of the BSVI emission norms was a complete watershed moment for the automotive industry.
Right, the Horat State Seath standards.
Yes, BSVI is a set of rigorous environmental regulations designed to drastically reduce air pollution from internal combustion engines. To meet these new, incredibly tight emission standards, engines could no longer rely on simple mechanical carburetors.
They just weren't precise enough, right?
Exactly. They required sophisticated electronic fuel injection systems and catalytic converters that demanded real-time, microsecond-level monitoring of the fuel-to-air mixture and exhaust output.
The old mechanical dials just couldn't process or display that level of granular data. I mean, they were too slow and too dumb.
Right. Overnight, the internal management of the vehicle had to become highly digital just to be street legal.
Wow.
And because about 60% of Pricol's sales are tied to these instrument clusters, a regulatory mandate that essentially outlaws old mechanical dashboards and forces industry-wide digitization is a profound structural tailwind for their business.
So it wasn't just consumers demanding cooler-looking screens with fancy graphics. The government regulations practically forced the upgrade by demanding a level of mechanical precision that only a digital nervous system could provide.
That's exactly it. And the second major force accelerating this transformation is the rise of electric vehicles, or EVs.
Which changes the game entirely.
It does. An electric vehicle fundamentally lacks a traditional combustible engine. It doesn't have mechanical oil pumps or traditional alternators.
Right, it's all battery and motors.
Yeah, it relies entirely on complex battery management, intricate thermal management for the high-voltage electrical systems, and literally millions of lines of software code.
So the dashboard has to reflect all of that.
Yes. The dashboard cluster in an EV has to integrate deeply with the battery systems to display dynamic range estimations, real-time discharge rates, and regenerative braking efficiency.
I have an analogy for this. It feels like we are watching the transition from old rotary dial telephones to modern smartphones.
Oh, that's a great comparison.
Right, because a rotary phone was a purely mechanical marvel. You spun the dial, gears physically clicked, and copper circuits mechanically opened and closed to send an electrical pulse over a wire. It did exactly one thing, make a voice call.
Very specialized, very mechanical.
Exactly. But a smartphone is a pocket-sized supercomputer that just happens to make calls among 1,000 other tasks. If every single vehicle on the road is becoming a rolling supercomputer, basically a smartphone on wheels, isn't Pricol basically graduating from being a traditional metal-bending auto parts supplier to a high-tech software and display company?
They are graduating, but they're executing this transition without abandoning their mechanical foundation.
How do you mean?
Well, a smartphone on wheels still interacts with the physical world. It still needs robust physical sensors to tell the software how fast the wheels are turning, and it absolutely needs physical thermal management systems, like high-tech fluid pumps, to keep the substantial battery packs from overheating and catching fire.
Oh, right. You can't just cool a massive battery with an app.
Exactly. Pricol is uniquely positioned because they speak both the language of software and the language of steel fluently. They can forge the metal for the electrical coolant pump in their ACFMS vertical, and they can write the complex code for the digital display that monitors that exact pump in their DICVS vertical.
Okay, but you just told me they make glass screens and fluid pumps. I mean, anyone with enough capital can buy glass, microchips, and steel.
Sure.
What is stopping a towering industrial conglomerate in Germany or some highly subsidized manufacturer in East Asia from just reverse engineering Pricol's fuel pump, manufacturing it for 10 cents less, and stealing all their clients tomorrow? Like, let's talk about the moat here.
Okay, well, the mechanics of automotive supply chains and defense strategies are truly fascinating when you look under the hood.
I bet.
The primary defense Pricol relies on is astronomically high switching costs.
Because it's hard to swap parts out.
Much harder than you'd think. To understand why those costs are so prohibitive, you have to look closely at the automotive validation cycle. You do not just design a part in a CAD program, manufacture a batch, put them in a cardboard box, and sell them to a car company.
It's not like buying a USB cable off the shelf at an electronics store. If a USB cable doesn't work, you just throw it away. But if a car part doesn't work, someone could die.
Exactly. The stakes dictate the process. From the moment an original equipment manufacturer, an OEM, approaches Pricol with the requirement for a new digital instrument cluster or a new high-pressure oil pump, to the moment that specific part actually generates a single rupee of revenue, it takes a 2.5 to 3 year cycle.
Wait, 2.5 to 3 years just for testing and design? That sounds like a pharmaceutical drug trial.
It is a very apt comparison, honestly. In pharmaceutical trials, you spend years proving the drug won't harm the patient before you can sell it.
Right.
In the automotive industry, you have to prove the part won't fail under the most extreme conditions imaginable over the expected lifespan of the vehicle.
Because failure is catastrophic.
Yes. If a fuel pump fails on a fully loaded commercial truck while it is navigating a steep mountain pass, or if a digital instrument cluster shorts out at night and the driver loses all visibility of their speed and engine temperature, the consequences are disastrous. The time-intensive validation process is absolutely intrinsic to automotive engineering standards.
Let's get specific about what that testing actually looks like. What are they doing to these parts for 3 years?
Oh, they subject the prototypes to brutal, relentless environments.
Like what?
They run thermal shock testing, where a digital screen is exposed to blistering heat, say, simulating the interior of a car parked in the desert summer, and then immediately plunged into freezing temperatures to ensure the glass doesn't shatter and the liquid crystals don't rupture.
Wow.
They perform extreme vibration testing, mounting the sensors on rigs that violently shake them for weeks on end to simulate decades of driving over potholed roads. This ensures the microscopic solder joints on the circuit boards don't crack.
That is intense.
They do moisture resistance testing, salt fog exposure to test for rust, and even electromagnetic interference tests to ensure a nearby radio tower won't scramble the digital dashboard's data.
So if I am that competitor in Europe and I figure out a highly efficient way to make a fuel pump that is 10% cheaper than Precol's, and I march into an OEM's office in India and say, hey, buy my pump, save millions of dollars, the OEM's response isn't going to be, great, let's sign a contract.
Not at all. The OEM is going to say, give us your prototypes, and we will talk to you in 3 years after you have passed every single one of our internal safety and validation protocols.
That is a massive wall to climb.
The relational inertia this creates is immense. Once an OEM has spent 3 years and significant engineering resources validating a Pricol component, and that component proves reliable in the field, replacing Pricol becomes an operational nightmare.
Because you have to start all over?
Right. The OEM would have to spend another 3 years and millions of dollars in testing resources just to switch to your slightly cheaper supplier. The risk of the new, unproven part failing in the real world and causing a sweeping multi-million-dollar vehicle recall far outweighs the marginal cost savings of switching suppliers.
The switching cost isn't just money, it's time and it's risk. That explains their market dominance perfectly.
It really does.
Our sources show that because of this deep trust and the sheer pain of switching, Pricol commands a 50% market share in domestic two-wheelers in India and an astounding 70% share in commercial vehicles in India.
Yes.
Globally, they are the second largest manufacturer of these components by volume. I mean, when you own 70% of the commercial truck dashboard market, you aren't just a supplier anymore. You are a structural load-bearing pillar in the industry's architecture.
It is near total saturation in the Indian commercial vehicle space. And, they protect that dominant position, not just with the validation moat, but with a severe structural cost advantage. This is the second layer of their defense strategy.
How big of an advantage?
They maintain a 10 to 25% cost advantage over the direct competitors in Europe and Latin America.
A 25% cost advantage in heavy manufacturing is a staggering margin. How are they achieving that? Is it purely labor arbitrage? Like, are they just paying lower wages in India?
Labor costs play a role, sure, but the advantage goes much deeper than just wages. What's fascinating here is their uncompromising commitment to backward integration.
I understand the basic concept of backward integration, owning more of your supply chain, but how does that actually look on the factory floor at Pricol?
It means that instead of buying the critical subcomponents and raw materials from third-party suppliers just to assemble the final product, you bring the heavy industrial manufacturing of those raw materials in-house.
Oh, I see.
A prime example from our sources is that Pricol doesn't just assemble fluid pumps. They manufacture their own sintered components.
Sintering. That is a metallurgical process, right? How does that work?
Think of packing a snowball. When you form a snowball, you aren't melting the snow into liquid water. But if you squeeze it hard enough in your hands, the intense pressure fuses the individual flakes together into a solid, dense block of ice.
Right.
Sintering applies that exact same physical principle to powdered metal. You take metal powder, press it into a specific mold under extreme pressure, and heat it just below its melting point. The particles fuse together into a highly precise, solid component without ever liquefying.
And doing this themselves saves them money.
Absolutely. By controlling this underlying metallurgical process themselves, Pricol captures the profit margin that a specialized third-party sintering supplier would normally extract. Furthermore, they gain absolute control over the quality tolerances and the supply chain timeline.
They aren't just ordering the meal and plating it. They own the farm, they grind the flour, and they bake the bread themselves.
Perfectly said. And they combine this deep backward integration with the undeniable geopolitical reality of being located in India.
Which helps
Because India is the second largest steel producer in the entire world. By having their manufacturing base localized near these abundant, cost-effective raw materials, they eliminate substantial international freight costs, import duties, and the logistical nightmare of shipping heavy steel across oceans just to begin the manufacturing process.
Okay, this raises a challenging question for me.
Let's hear it.
I see in the sources that this cost advantage is so strong that when they export their products to those 45-plus countries, they are seeing profit margins of up to 20% on those exports.
Yes.
That is highly profitable. But if their entire export strategy relies on being the cheaper option compared to a European manufacturer, aren't they incredibly vulnerable? What stops someone else from just building a cheaper factory somewhere else, say in Vietnam or Eastern Europe, and undercutting them?
Well, building a cheaper factory somewhere else only solves the labor part of the equation.
Okay.
A competitor setting up shop in a new geography would still have to replicate the deep backward integration. They would have to build their own expensive sintering facilities.
Which takes a lot of capital.
A lot. They would still have to secure a localized, reliable supply of high-grade steel at the volume and price that India naturally offers. And most importantly, even if they achieved all of that, they would still have to run headfirst into that 3-year validation wall with the major OEMs.
Ah, the validation wall again.
Exactly. Precol's moat isn't just one thing. It is the interlocking combination of the 3-year lock-in, the in-house backward integration, and the geographic resource advantage. You cannot easily or cheaply replicate all three simultaneously.
That makes perfect sense. It's a fortified ecosystem. So we know they make these incredibly complex parts. We know they have this broad transition from mechanical to digital pushing their sales. And we know their market share is fiercely defended.
Right.
Now, I want to explore how this all actually translates to the bottom line. Let's look at the financial engine of Pricol. And to be clear for the listener, we are looking strictly at the operational mechanics of how they generate cash here.
The most powerful dynamic in their operational financials right now is the magic of premiumization.
Premiumization.
Yes. We talked earlier about the transition from mechanical dashboards to digital screens, forced by regulations like BSVI. That transition is the single biggest margin multiplier for the company.
How does that multiplier work in practice?
Let's look at a critical industry metric called content per vehicle, or CPV. This measures the total monetary value of all the parts Pricol supplies for a single specific vehicle.
Okay.
When an OEM switches a motorcycle design from an old mechanical cluster to a basic digital LCD screen, Pricol's content per vehicle multiplies 3 to 4 times.
Wait, just by switching to a basic digital watch-style LCD screen, they are making 3 to 4 times more money on the exact same motorcycle.
Yes, because the embedded electronics and software are vastly more valuable than a plastic dial and a spring. But, it gets even better.
How so?
When the OEM decides to upgrade that basic LCD screen to a full-color, high-definition TFT screen, the kind you see on premium motorcycles and modern cars, the content per vehicle multiplies 10 to 15 times compared to the old mechanical parts.
10 to 15 times. For the non-engineers listening, what makes a TFT screen fundamentally different and clearly much more expensive than the basic LCD on, like, my old digital alarm clock?
Sure. A standard LCD, or liquid crystal display, relies on a passive matrix. It is good for displaying simple numbers or blocky shapes like a calculator, but it is slow and lacks contrast.
Right.
A TFT, or thin film transistor display, uses an active matrix. Every single pixel on the screen is attached to its own microscopic transistor.
Oh, wow.
Yeah, this allows for rapid refresh rates, complex full-color graphics, and crucially for vehicles, intense brightness and contrast. A motorcycle dashboard has to be perfectly legible in direct, blinding high-noon sunlight.
That makes sense.
Achieving that level of thermal stability and optical brightness with a TFT screen requires sophisticated engineering and expensive materials, which totally justifies the 10 to 15 times price premium.
10 to 15 times. It's like a restaurant that used to sell a $5 burger, but now a new health law requires everyone to eat a $50 steak.
That's a fun way to think about it.
Right. The customer is sitting at the exact same table, taking up the exact same amount of space in the restaurant, but the revenue generated from that seat just went up tenfold.
That analogy perfectly illustrates the power of premiumization. They don't necessarily have to sell more total parts or expend resources finding entirely new customers to grow their revenue exponentially. They simply have to sell these much more sophisticated premium parts to their existing captive audience of OEMs who are locked in by the validation cycle.
And the kitchen making these $50 steaks seems to be highly efficient. Our sources indicate that Pricol operates at roughly an 85% capacity utilization rate across their plants.
They do.
So if I understand capacity utilization correctly, they've already paid for the factory, the lights are on, the workers are there, and they are running at 85% of their maximum physical output. Explain how that impacts their underlying profitability.
This brings us to the fundamental physics of operating leverage in heavy manufacturing. You have fixed costs and variable costs.
Okay, basic economics.
Right. Fixed costs are the colossal expenses you incur before you even turn a machine on. The factory building itself, the heavy manufacturing machinery, the administrative salaries, the years of research and development. You pay these substantial sums regardless of whether you produce one instrument cluster or 1 million.
Yeah.
Variable costs, on the other hand, are the raw materials, the steel, the plastics, the microchips, which scale linearly with how much you actually produce.
Right. If you don't build a digital screen, you don't have to buy the glass for it. The variable cost drops to zero.
Exactly. Because Pricol has a very high fixed cost. Base building and maintaining 9 precision engineering factories is incredibly expensive. They need to produce a substantial volume of parts just to break even and cover those fixed costs.
Makes sense.
But once they cross that break-even threshold, a fascinating economic phenomenon occurs. Every new unit sold above that threshold brings superlinear operating profit growth to the bottom line.
Because the factory mortgage and the machinery are already paid for by the previous units, the only cost for that one extra unit is the raw material and a tiny fraction of labor.
Yes, the fixed costs become proportionally smaller and smaller as the total revenue grows. So as they push their capacity utilization from 85% closer to 90 or 95%, their operating margins expand significantly.
The profits shoot up.
Right. The gross revenue goes up,
Yeah.
but the underlying cost to run the company doesn't go up at the same rate. This is why management is confidently targeting an EBITDA margin, which is essentially their core operating profitability before accounting for things like taxes and depreciation of around 13.5%. They're squeezing progressively more profit out of every incremental unit produced.
And here is a detail from the sources that genuinely surprised me. In a heavy manufacturing company of this size, you usually see a lot of debt, but Pricol has zero long-term debt.
It's very uncommon.
The company has been completely free of long-term debt since the second quarter of the financial year 22.
That is a remarkable structural achievement for a capital-intensive manufacturing business. Usually, companies in this space are heavily leveraged.
They borrow to build, right?
Exactly. They borrow enormous sums of money from banks to build new plants or upgrade their machinery. That means a significant portion of their operating profit goes straight out the door every month just to pay interest to the bank.
Right.
By operating with zero long-term debt, Pricol keeps that cash. It gives them immense flexibility to weather severe economic storms or to aggressively self-fund their own expansion without begging lenders for capital.
It is like owning your house free and clear. Your required monthly expenses plummet, and all your disposable income can go toward renovations, investments, or just building a huge emergency fund instead of paying a mortgage.
That's a perfect analogy.
And we can clearly see the momentum of this financial engine in their recent numbers. In the first quarter of the financial year 26, their revenue jumped 44.35% year over year.
Incredible growth.
They hit 895 crore rupees in a single quarter.
That 44% jump is the physical manifestation of everything we just analyzed.
How so?
Well, it reflects the post-pandemic recovery in the domestic two-wheeler market. It highlights the significantly higher selling prices of those complex TFT digital screens, and it demonstrates their operating leverage working perfectly as those factories run closer to maximum capacity.
All the cylinders are firing.
Exactly. They are selling much more expensive parts to the exact same customers. Their factories are humming efficiently, and they don't have to pay a single rupee of interest on long-term loans.
It is a beautifully tuned operational engine, but sitting still in the automotive industry is basically a death sentence right now.
Without a doubt.
The transition to electric and autonomous vehicles is moving faster than anyone predicted even 10 years ago. So, with this highly profitable legacy business generating cash and zero debt weighing them down, where is Pricol deploying their capital? Let's trace the roadmap and explore where they believe the future of their growth lies.
The most urgent pivot they are making is into the electric vehicle space.
The EV market.
Yes. The internal combustion engine might remain relevant for a while, particularly in commercial trucking, but the primary growth vector of the entire industry is clearly pointing toward EVs.
Right.
To capture this, Pricol isn't just trying to slightly adapt their old mechanical parts. They are actively partnering to build entirely new critical electronic systems. They have partnered with a technology company called BMS PowerSafe to build end-to-end battery management systems, or BMS.
Let's define what a battery management system actually does, because if I hear battery management, I just think of a glorified fuel gauge that tells me my battery is at 80%.
Oh, a BMS is vastly more complex and critical than a simple fuel gauge. It is the primary safety and performance brain of an electric vehicle.
How so?
Well, lithium-ion batteries, which power modern EVs, are chemically volatile.
Right.
If they overcharge, they can overheat and literally catch fire in a process called thermal runaway.
Oh, wow.
If they discharge too quickly, their internal chemistry degrades, permanently ruining the battery's capacity. If they get too hot or too cold from ambient weather, their efficiency plummets.
This is very delicate balance.
Extremely delicate. A BMS constantly, meticulously monitors the exact voltage, temperature, and current of every single individual cell within a substantial battery pack. It actively balances the charge across thousands of cells, controls the thermal liquid cooling systems, and ensures the entire battery architecture operates safely within strict physical parameters.
So if the BMS fails, the vehicle is not just stranded on the side of the road with a dead battery. It could potentially become a dangerous fire hazard.
Exactly.
That circles right back to Pricol's core competency: high-stakes reliability and intense multi-year validation testing.
They are taking their hard-won reputation for zero-failure precision engineering in fluid pumps and dashboards and applying it to the single most critical, dangerous component of the EV architecture.
That is a smart pivot.
And they are executing this strategy aggressively. According to the sources, they are currently working with around 28 different EV original equipment manufacturers in India who are currently in the startup or development phase.
Okay, I have to pause you there and push back on this specific strategy.
Sure, go ahead.
I get the ambition, but 28 different EV startups?
It sounds like a lot.
It sounds chaotic. It is one thing to dominate the legacy two-wheeler space where you are working with established giants who predictably order millions of parts year after year. But working with 28 different EV startups sounds incredibly risky. Like, let's be honest about the startup world.
It's volatile.
Highly volatile. I get the venture capital approach of spreading your bets, but VC firms fully expect 9 out of 10 of their startups to fail completely. If Pricol is spending millions of dollars and years of engineering time customizing complex battery systems and dashboards for 25 companies that are going to go bankrupt before they ever manufacture a single car, isn't that just lighting their R&D budget on fire?
You are identifying the exact structural risk of the EV transition, and your skepticism is totally warranted.
Thank you.
Out of those 28 startups, historical industry consolidation suggests perhaps only 5 or 6 will survive to achieve meaningful mass production.
Right.
It is highly probable that Pricol is currently engineering parts for companies that will not exist in 5 years. But look at it from their perspective.
Yeah.
Because the automotive validation cycle takes 3 full years, Pricol must be deeply integrated with these companies during their initial development phase.
Right, but why not just wait to see which 2 or 3 startups emerge as the actual winners and then partner with them?
Because if they wait 3 years to see who wins the market share war, they will be 3 years too late to supply the winner.
Ooh.
Yeah. The winning startup will have already validated a competitor's BMS and dashboard. The switching costs we discussed earlier will lock Pricol out of the market entirely.
I didn't think about that.
They are forced to engage in this necessary inefficiency. They have to spread their engineering resources across all 28 players now, absorbing the R&D losses of the failures. To guarantee that no matter which of those startups eventually dominates the Indian EV market, Pricol's technology is already permanently woven into the vehicle's DNA.
I see the bind they're in. It is an expensive insurance policy against obsolescence. They have to play the entire field because they can't afford to miss the one breakout star.
Exactly. And while they're casting that wide net in EVs, their second major growth vector is focused on the software side of connected vehicles.
Like the telematics we mentioned.
Yes. They have formed strategic technology tie-ups with specialized software companies like Candera and Cebros. This represents a move toward deep operating system-level software integration. The adoption of connected clusters in India, meaning dashboards that don't just display speed, but actively communicate with cloud-based fleet management software, download over-the-air performance updates, and track vehicle telemetry in real time, is expected to jump from roughly 15% back in 2020 to over 50% by 2025.
That is a sweeping technological leap for the domestic market. Moving from 15% to over 50% adoption in just 5 years means the entire landscape of the Indian automotive market is shifting from isolated dumb screens to perpetually connected smart interfaces.
And to fuel all of this ambition, the widespread EV pivot, the complex battery management systems, and the deep connected vehicle software integration Pricol is unleashing a highly targeted capital expenditure plan.
They're spending that cash they saved.
Yes, because they maintain that zero long-term debt profile we discussed, they have the unencumbered financial firepower to invest aggressively. They have formally planned a 600 crore rupees capital expenditure over the next 7 to 8 quarters.
That's a lot of money.
The ultimate strategic goal of this heavy investment is to unlock the capacity required to hit a future revenue target of 4,000 crore rupees.
600 crore rupees over basically 2 years. That is a substantial outlay of cash. What exactly are they buying with all that capital?
It is a calculated mix of modernizing their existing footprint and expanding it into new territory. A portion of it goes to upgrading their current plants to handle the delicate, clean room requirements of advanced electronics and digital product suites.
Okay, making the old factories better.
Right. But a significant portion is dedicated to adding completely new capacity, specifically a greenfield manufacturing plant in Pune.
Clarify greenfield plant for me.
Greenfield plant means they're not buying an old defunct factory and trying to retrofit it. They're acquiring empty, undeveloped land, a greenfield, and building a state-of-the-art facility from scratch.
Nice.
This allows them to design the factory floor layout, the robotics, and the supply chain logistics specifically for the next generation of EV components and connected displays, unconstrained by legacy architecture.
So they are purposefully building the physical infrastructure required to assemble these highly complex battery systems and TFT screens at a towering scale.
Yes, and crucially, that expanded capacity isn't just intended to serve the domestic Indian market. The final piece of their growth roadmap is an aggressive push into global exports, specifically riding the macroeconomic tailwinds of the China Plus One supply chain shift.
China Plus One. For the listener who might not live and breathe global supply chain economics, that is the international corporate strategy where multinational companies want to diversify their manufacturing away from relying solely on China, right?
Yes, precisely.
Following the pandemic and various trade tensions, they want a backup plan, a plus one country, to protect their assembly lines against sudden logistical disruptions or geopolitical tariffs.
That is exactly the dynamic at play. India is aggressively positioning itself at a national level to be that primary plus one destination for global automotive components.
And Pricol is jumping on that.
They are. Currently, Pricol's exports sit at a relatively modest 8.15% of their total sales. But their stated strategic target is to push that to 20% of their consolidated revenues.
That's a big jump.
And they are already seeing major tangible wins in this area. They recently won a substantial global contract with Renault to supply critical fluid pumps.
That Renault contract feels like an enormous validation of their strategy. If a global giant like Renault trusts your engineering enough to supply critical fluid management systems for their international fleet, that effectively serves as a seal of approval that opens doors with every other major automaker in Europe and North America.
It's a huge foot in the door.
Right. So when you look at this whole roadmap from a high altitude, they are using the incredible cash generation from their dominant legacy business, the mechanical pumps and the entrenched two-wheeler clusters, to fully fund this high-tech future of EV battery management and sweeping global export expansion.
If we connect this strategy to the bigger picture, the runway for growth is extensive. Around 40% of the domestic market is still open for them to capture from competitors, and almost the entirety of the emerging global EV supply chain opportunity is wide open.
Yeah.
The roadmap appears solid, it is funded internally without toxic debt, and it aligns perfectly with the overarching macro trends of the global automotive industry.
It sounds almost inevitable when you lay it out with that level of clarity. But, and this is a very important, but no business operates in a vacuum. Every smooth road has potholes. To give our listener a truly objective, complete picture of Pricol, we have to stress test this optimistic growth story. We need to look closely at the serious operational risks that could derail this entire trajectory. Let's dig into the potholes.
It is absolutely crucial to examine these vulnerabilities because the exact same operational mechanics that make Pricol highly profitable in good times can work against them brutally during bad times.
What's the biggest threat?
The most immediate, persistent, and uncontrollable threat they face is severe input cost volatility.
You are talking about the daily fluctuating price of the raw materials they use to build these parts.
Yes. Their profit margins are exquisitely sensitive to the global commodity costs of high-grade steel, specialized industrial polymers, and intricate electronic components.
Which they use a lot of.
They consume an enormous volume of these materials. If a geopolitical conflict in the Middle East causes oil prices to spike, the cost of the petroleum-based polymers they use for plastic housings skyrockets.
Right.
If global shipping lanes constrict or a microprocessor factory in Taiwan faces delays, electronic component prices surge unpredictably.
And normally in a standard consumer business, if the cost of flour goes up, the bakery just passes those extra costs on to the customer by raising the price of a loaf of bread.
Normally, yes. But the automotive industry is uniquely punishing in this regard. OEMs wield towering negotiating power over their suppliers.
They dictate terms.
They do. They operate on notoriously thin margins themselves, and they fight every single price increase bitterly. We have concrete evidence in the sources of how damaging this power dynamic can be for Pricol.
Really? What happened?
In the 2024-25 period, Pricol actually suffered a cash loss, specifically because their OEM customers flat out refused to accept price increases intended to offset the rise in raw material costs.
Wait, really? So the cost to manufacture the fuel pump went up due to global commodity prices? The car company refused to pay a single rupee more for the finished product, and Pricol was forced to absorb the entire difference, completely wiping out their profit on those specific parts.
That's exactly what happened.
That is a brutal reality check. It shows that despite commanding a 70% market share in commercial vehicles, they do not possess absolute pricing power. The OEMs can still dictate terms.
They absolutely do not have infinite pricing power. And that vulnerability to input costs is deeply compounded by the second major pothole: severe sector cyclicality.
The booms and busts.
Yes. The automotive market, particularly the two-wheeler and commercial vehicle segments that Pricol relies on so heavily for cash flow, is notoriously cyclical. It goes through dramatic booms, and then it goes through crushing busts.
Depending on the economy.
Exactly. People and businesses buy new trucks when the broader economy is thriving and interest rates are low. They immediately delay those expensive purchases when interest rates rise, inflation spikes, or economic growth slows.
And when the OEMs realize consumers aren't buying, they stop building trucks. And when they stop building trucks, they instantly stop ordering dashboards and pumps from Pricol.
Precisely. And this is not a theoretical risk model. It is a historical reality.
When did this happen before?
In the 2014-15 period, the global automotive industry experienced a steep, sudden production drop. Major global OEMs like Kawasaki, operating in Thailand and Indonesia, and Piaggio in Italy, severely cut their production volumes in response to weakening consumer demand.
And that hit Pricol.
The ripple effect of those cuts hit Pricol's order books immediately, leading to significant financial losses during that period.
Let's connect this historical cyclicality back to what we discussed earlier about the physics of operating leverage.
Okay.
You mentioned that because they have towering fixed costs, those expensive factories and equipment, every unit sold above the break-even point generates superlinear profit. But doesn't that exact same mathematical principle work in reverse when orders dry up?
It works viciously in reverse. This is the double-edged sword of manufacturing leverage. If OEM demand drops suddenly and Pricol's factory capacity utilization falls from 85% down to, say, 60%, those fixed costs do not magically disappear.
The mortgage still has to be paid.
Right. The factory still requires expensive electricity, the advanced machinery still requires constant maintenance, and the 5,500 employees still require salaries.
Yeah.
Suddenly, because there are fewer parts rolling off the line, every single individual part produced carries a much, much heavier burden of those fixed costs. Profitability collapses incredibly fast, often faster than management can cut variable expenses.
Which makes their current strategy of spending 600 crore rupees on new greenfield factories slightly terrifying if the market suddenly turns. You are expanding capacity right before a potential cyclical downturn.
It's a huge gamble.
That brings up the third risk mentioned in our sources: CapEx execution risk. Capital expenditure expansion is fantastic if the consumer demand materializes to fill the factory. Right. But if you build a sprawling greenfield plant in Pune specifically for EV components, and the Indian EV market suddenly cools off due to a lack of charging infrastructure, you are left with an empty, incredibly expensive building.
It is a monumental financial risk. Misallocating capital during aggressive expansion phases has crippled many manufacturing companies. And again, we don't have to look outside of Pricol's own history to find a cautionary tale.
They stumbled before.
Yes. A former Pricol subsidiary known as PIPL previously suffered a devastating blow. They lost 75 to 80% of their total revenue after exiting a specific automotive segment and attempting to pivot their manufacturing capabilities toward the railways and defense sectors.
Losing 80% of your revenue because a strategic pivot failed. That is a sobering case study.
It's a very harsh lesson.
It illustrates exactly what happens when expansions, strategic realignments, or attempts to enter entirely new industries go wrong. You can hemorrhage the vast majority of your revenue stream incredibly quickly if the execution isn't flawless.
It highlights the danger of straying too far from your core competencies or, misjudging the timeline of a new market's adoption curve. And finally, we must consider the distinct risks associated with their grand export ambitions.
The push for 20% exports.
Right. They want to jump from 8% to 20% in exports to capitalize on the China plus one shift.
Right.
But global markets are arguably even more volatile than domestic ones.
I would assume so because you are dealing with a multitude of uncontrollable variables. Sudden currency fluctuations, spiking international shipping container costs, and the disparate economic health of multiple different continents simultaneously.
Exactly. And we saw this exact vulnerability manifest recently. A macroeconomic slowdown in the United States and Europe, driven by central banks raising interest rates to combat inflation, temporarily reduced Pricol's organic export revenue guidance.
By how much?
They had to formally revise their revenue target down from 3,600 crore rupees to 3,200 crore rupees.
A 400 crore rupee haircut to their projections simply because interest rates in the US or Europe slowed down consumer spending half a world away. So, what does this all mean? How do we intellectually balance the incredible profitability of their digital premiumization transition against these very real, very dangerous threats of raw material spikes, OEM pricing pressure, and global economic slowdowns?
Well, it means that Pricol is currently walking a highly engineered, deeply fascinating tightrope. Their structural advantages, the debt-free balance sheet, the impenetrable 3-year validation moat, and the deep metallurgical backward integration provide an incredibly strong safety net beneath them.
The safety net is essential.
That zero long-term debt profile is crucial. It means they can survive a cyclical automotive downturn or a misstep in EV adoption without immediately defaulting on crushing bank loans. But the tightrope is still swaying in the wind.
It's a tricky balance.
They're attempting to strike a delicate, perilous balance between aggressively financing a forward-looking expansion into next-generation EVs and managing the harsh daily realities of negotiating raw steel prices with notoriously stubborn automotive giants.
It is a remarkable dynamic to observe. They are not just coasting on their legacy mechanical successes, they are actively, aggressively engineering their way into a digital future while trying to manage the immense gravity of present-day manufacturing realities. As we wrap up this deep dive, let's briefly retrace the extensive journey we have taken through the sources today.
Sounds good.
We started by uncovering the sheer scale of Pricol Limited, an Indian automotive titan that is quietly but forcefully powering the transition from mechanical combustion engine vehicles to fully connected digital and electric machines.
The transition is huge.
We explored how their market dominance is protected by an almost impenetrable 2.5 to 3 year validation moat, effectively locking OEMs into long-term relationships based on critical safety standards and the sheer pain of switching suppliers.
Right.
We looked under the hood of their incredibly efficient operational financial engine, noting that they are entirely free of long-term debt and how the regulatory shift to premium digital TFT screens acts as a staggering multiplier for their revenue per vehicle.
The premiumization magic.
Exactly. But we also navigated the substantial potholes, recognizing that their aggressive expansion into the unpredictable EV startup space and global export markets leaves them heavily exposed to the volatile whims of global raw material costs, the negotiating power of OEMs, and the brutal cyclicality of global auto markets.
It is a comprehensive, objective picture of a manufacturing company standing at a critical strategic inflection point, utilizing the immense strength of its legacy mechanical business to entirely finance a high-tech, software-driven future.
And that brings us back to where we started. The next time you slide into the driver's seat, the next time you turn the key or push the start button on a two-wheeler or a heavy commercial truck, take a brief moment before you put it in gear.
Spaz.
Yeah, look at that digital dashboard lighting up. Think about the intense, multi-year engineering validation cycle, the thermal shocks, the relentless vibration testing that ensures that pristine glass screen won't fail you on a dark highway. Think about the unseen sensors and fluid pumps working in perfect engineered harmony beneath you, and recognize the sweeping global digital revolution happening right there behind the glass.
And as you think about that complex digital dashboard, I want to leave you with a provocative question to ponder, something that stretches beyond the current data we've discussed today.
Ooh, let's hear it.
The entire global automotive world is rushing headlong toward fully autonomous driving and fundamentally software-defined vehicles. If we extrapolate this technological trend to its logical conclusion, will we eventually reach a point where the physical dashboard, the actual instrument cluster itself, disappears completely?
Oh, wow.
If the car drives itself flawlessly, and if all the necessary passenger information is relayed entirely via natural voice interfaces or augmented reality graphics projected directly onto the empty windshield, how does a hardware-centric precision engineering company like Pricol adapt? When the physical screen is no longer required to drive the car, how do the architects of the digital cockpit survive in a world without dashboards?
Now, that is a profound thought that will definitely stick with you on your next drive. Keep looking beneath the surface, and we will see you on the next deep dive.